Now let's discuss some pillar concepts of OOP with Python, one being method overloading. So we'll create one file, method overloading demo.py. In method overloading, basically, you have the same function within the class, same function name, uh, but it differs by the number of parameter or the type of parameter, and that is how you overload a particular function. This is not as much mature as in the case of uh, some languages like Java or C. uh, Here you can implement a relevant function using args, qwargs. However, there is another technique of implementing somewhat similar to how an implementation of Java or C is, using functool single dispatch method. So that is what I will demo in this particular video. From functools, import single dispatch method. We create a class. We create a function. We raise not implemented error and pass the message as unsupported type. Now we decorate this method to something like this, and now we can do some dot register. This function will have no name. Now this, let's keep this as int, b equal an int, and here we can return int operation. Similar thing, here we can return str operation. We instantiate the class now, and we call the sum, passing 1 comma 1, and here we will sum string. We can print this. Right, and this is kind of like a polymorphism, single name many form, single method doing multiple things. One more thing related to polymorphism is method overriding. So we will create one file, method overriding demo.py. And to understand this method overriding, I think so inheritance concept is much more better. So inheritance is considered as to be one of the most uh, pillar most concept in object oriented programming, wherein you see classes in the form of relationship. There is parent class and then there is child class, and this whole coding technique helps to reduce the uh, code, and it increases the purpose of code reusability. So there can be classes at the parent level which can have certain methods that can be directly be inherited to some child classes, right? So the way inheritance eventually function can also differ. There are multiple types. There is single level inheritance, wherein single child will have a single parent. There is multi-level inheritance, wherein uh, there are class A, B, C, and within C is inheriting to B, B is inheriting to A. Basically, at single level there will be single class and single child. At multi-level there will be single one class being acting as a parent to another class, and this class acting as a parent to another class. Okay, then there is a hierarchical, wherein all of the class is pointing to uh, having has the same parent, right? So hierarchical is where all of the child class has the same parent class. Now there is multiple inheritance also. So here basically a child class can have multiple parent class. So consider this is as a child class and this has been inherited from a comma b. This is also permissible. And then there is hybrid inheritance that promotes mix of all the previous thing that we just discussed. Okay, to demo this and basically demo eventually the method overriding, let's create one class a. This has some method self, and we pass this return a. Then we have this class b. This is inheriting to a, again self, and here we return b. Now we create the object of b and we call sum. When we will print it, right? So basically this method has overridden the parent class now, and it has this is how method overriding works. Now there is this important concept that we just touched upon, a multiple inheritance. In multiple inheritance there are chances of collision and everything, because uh, how does Python decide which class to prefer if they have common methods among them, right? So uh, this problem is solved using a concept called as MRO, method resolution order. uh, we can understand this in depth. Consider we have a class a, right? And for the time being I'm simply passing it. Then consider we have a class b. We can pass this. We have a class c. Pass this. We have a class d. Now class d is inheriting from class b and c both, right? Now consider accessing what will be the MRO for this d class. We can check this using the lambda method d dot MRO. If we execute this, we get d. Then this is called as L3 C3 linearization algorithm. Whichever class was passed as first, and your pathway will select that class as the first most element to check with all of its method. So d will get forward to b, then it gets forward to c, right? N- there is one nuance over here that one needs to remember. For instance, if b would be inheriting to a and c would be inheriting to a, let me actually copy paste this to demo. So if b is inheriting to a and c is inheriting to a, in this particular case what will happen, d will go to b, then again b will go to, after this it will come back and it will go to c and then it will go to a. And if this wouldn't have been taken place, like if we had one more class as d, and let's say d is inheriting to c and c is inheriting to, c is not inheriting to anyone and b is inheriting to a, and like now let's suppose we have class e where we are inheriting from d and b. Now in this case, the MRO will be like, the MRO will be E, T, then C, then B, then A. Right. I forgot to override this thing. So now you can check E, D, then it goes to C, then it goes to B, then it goes to A. And if you compare over here, because B and C were inheriting to the same parent class, so that's why first your MRO mm, started from D, then it went to B, then it went to C, and then it went to A. One more important concept in this object oriented programming fundamentals is operator overloading in Python. So we can create a file for this, overloading.py. So all of this operator that we time and again work upon, like plus, minus, divide, multiply, whenever we perform this operation internally, all of this operator has their own danda method. So for plus it is underscore underscore add underscore underscore. For multiplication it is underscore 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 underscore. For subtraction it is underscore underscore sub underscore underscore. For division there are two. There is true div and then there is flow div. Okay. So here we aim to overload the operator. So we can create a class A. This will have init self comma other, sorry, self comma value, and here we just initialize the value to this self dot value equal to value. Now we can overload the add function, add operator, self comma other. This accepts this other value also. We can check here what is the instance of this other. If it is the same as that of this class, so we need to return a self dot value plus other dot value. Otherwise we can return a self dot value plus other. Similarly, like I have written add, you can write mul, sub, true div, flow div and all. We instantiate this by passing value as 1. We again instantiate this by passing value as 2. And now we can do a1 plus a2 dot value. And if we execute this now, operator overloading demo dot py, right? We are getting this. Similarly, we have also enabled the support if this a2 is not part of the class. So this can be 4 together, and even this would work fine. Okay. Now inside this add, you can perform multiple operation. You can have some kind of if condition, and that is how you are doing the overloading thing.